So what's up guys, for today's vlog I will be summarizing the chapter 5, which is Ethernet. So we have a LLC sublayer. The Ethernet LLC sublayers handles the communication between the upper layers and lower layers. This is typically between the network software and the device hardware. The LLC sublayer takes the network protocol data, which is typically IPv4 packet, and adds control information to help deliver the packet to the destination node. The second is MAC sublayer. MAC sublayer constitutes the lower sublayer of data link layer. MAC is implemented by hardware, typically in the computer and IC. The specific are listed in the IEEE 802.3 standards. Frame delimiting. The framing process provides important determinators that are used to identify a group or bits that make a frame. These delimiting bits provide synchronizations between the transmitting and receiving nodes. So, addressing the encapsulation process contains the layer 3 PDU also provides for data link layer addressing. So the third is error detection. So error detection, each frame contains a trailer used to detect any errors in transmissions. Fast forward switching. Fast forward switching offers the lowest level of latency. Fast forward switching immediately forwards a packet after reading the destination address. Because fast forward switching uh, um, starts forwarding before the entire packet has been received. There may be times when packets are delayed with errors. This occurs infrequently, and the destination network adapter discards the faulty packet upon receipt. It fast forward mode latency is measured from the first bit received to the first bit transmitted. So the fragment free switching. In fragment free switching, the switch stores the first 64 bytes of the frame before forwarding. Fragment free switching can be viewed as a compromise between star and forward switching and fast forward switching. The reason fragment free switching stores only the first 64 bytes of the frame is that most network errors and collisions occurred during the first 64 bytes. So let's proceed to port-based memory buffering. In port-based memory buffering, frames are stored in keys that are linked to specific incoming and outgoing ports. A frame is transmitted to the outgoing port only when all the frames ahead of in the unique have been successfully transmitted. It is possible for a single frame to delay the transmission of all the frames in temporary because ABC. So second is share memory buffering. So shared memory buffering deposits all frame into a common memory buffer that all the ports on the switching share. The amount of buffer memory required by a port is dynamically allocated. The frames in the buffer are linked dynamically to the destination port. This allows packets to be received on the port then transmitted on other port without moving to a different key. Full duplex. Both ends of the connection can send a receive simultaneously. Half duplex. Only one end of the connection can send at a time. So destination MAC address. The MAC address of the internet NIC, which will be either the MAC address of the final destination device or the router. So source MAC address, the MAC address of the sender Ethernet NIC. So to determine the destination MAC address, the device user's ARP or ARP provides two basic functions. We have resolving IPv4 address to MAC address, and maintaining a table of mappings. So the video demonstration ARP request. So target IPv4 address. This is the IPv4 address that requires a corresponding MAC address. Target MAC address. This is unknown MAC address and will be empty and the ARP request message. The third is destination MAC address. This is a broadcast addressing requiring all Ethernet NICs on the LAN to accept and process the ARP request. So source MAC address. This is the sender of the ARP request MAC address. The last is type. ARP message have a type field of 0 times 806. This informs the receiving NIC that the data portion of the frame needs to be passed to the ARP process. Video demonstration ARP reply. Sender's IPv4 address. This is the IPv4 address of the sender, the device whose MAC address was required. Sender's MAC address. This is the MAC address of the sender, the MAC address needed by the sender of the ARP request. So destination MAC address. This is the MAC address of the sender of the ARP request. Source MAC address. This is the sender of the ARP replies MAC address. And the type. ARP message have a type field of 0 times 06. This information receives INC that data portion and frame needs to be passed and RAP process. So destination on same network. Physical address, the MAC address. Used to Ethernet NIC communication on the same network. And second is logical address, used to send the packet from the original source to the final destination. Duplex and speed settings. So we have two, full duplex and half duplex. So the full duplex, both ends the connection can send and receive simultaneously. And the second is half duplex. Half duplex, only one end of the same connection can send at time. Forward examining the destination MAC address. So if the destination MAC address is the table, it will forward to the frame out the specific port. If the destination MAC address is not in the table, the switch will forward the frame out all ports except the incoming port. This is known as an unknown unicast. As is shown in figure 2, the switch does not have the destination MAC address in its table for PCD. So the last is MAC address structure. The MAC address value a direct result of IEE enforced rules for vendors to ensure globally unique address for each Ethernet device. The rule established by IEE required any vendor that sells Ethernet devices to requires with IEE assigns the vendor a 3-byte or of 24-bit code called the Organizationally Unique Identifier OUI. So IEE requires a vendor to follow two simple. So we have all MAC address assigns to NIC or other Ethernet device must that vendors assigns OUI as the first 3 bytes. So all MAC address with the same OUI must be assigned a unique value in the last 3 bytes. And the MAC address hexadecimal. So representing hexadecimal values is usually represented in text by value preceded by 0 times or the subscript 16. Less commonly, it may be followed by an, however, because subscripts text in not or programming environments. So the hexadecimal conventions is Number conventions between decimal and hexadecimal values are straightforward, but quickly dividing, multiplying by 16 or is not always convenient if such conventions are required. It is usually easier to convert the decimal or hexadecimal value to binary, and then convert the value or either decimal or hexadecimal as appropriate. Thank you.